Hello and welcome students. This is yet another lecture on matrices, and in the last lecture of matrices I had taught you the transformations on matrices, that is elementary row transformation and elementary column transformation. So in this lecture we are going to take few questions. We are taking problem from exercise 2.5, and we are referring to the textbook of Maharashtra State Board, this textbook. So let us start with the questions. So here we have a question, and the question goes as follows. We have to apply this particular row transformation on this question. Okay, so the first one is we are given a matrix and we have to apply R1 interchange to R2. So see, the answer for the first one will be very simple. Answer for the first one. What is the row transformation? R1 interchange to R2. See, this all we have done. If you want a revision, you can just watch the previous video to this video. R1 interchange to R2. So what you will get, see students, you will get here R1 and R2 interchange. So R1 will be 2, 2 and R2 will be 3 minus 4. You can understand how easy this one is. Okay, now the second one. In the second one, what we have C1 interchange to C2. We will interchange C1 and C2. So here we have C1 interchange to C2. So you have 4 minus 5, 4 minus 5 to 1. This is C1 interchange to C2, 4 minus 5, C1, C2 interchange. Then we have the answer for the third one. In the third one, we have two questions. They demand us two transformation. One is 3R2, and the other transformation that they demand is C2 changes to C2 minus 4C1. Okay, so let me go for the answer for the third one. So in the third one, I call this one as A, and this one is B. Okay, so let me go for A. Now so when I go for A, what I get? 3R2. Now listen students, when they say 3R2, remember that when you go for 3R2, this R2 will change. How will it change? It will change as every element of R2 will be multiplied by 3. So I would write this more specifically. I will write it as R2 changes to 3R2. That would have been the perfect. Okay, R2 changes to 3R2. And what you will get here in that case, students, see, if you're doing this, R2 would change, R1, R3 will remain same. So 3, 1 minus 1, 3, 1 minus 1, and R3 minus 1, 1, 3, same. R1 and R3 same. R2 would change. 3, 9, and 3. 3, 9, and 3. R2 would change. Then you have this one, B. What is B? C2 changes to C2 minus 4C1. C2 minus 4C1. See that minus 4C1 is same as C2 plus minus of 4C1. Now, why do I take it this way? See, you might be thinking that when it was C2 minus 4C1, why do we have to write this? See, absolutely no issue. If you want to take it this way, you can take it this way. No worries at all. Okay, but then I prefer, it is one's preference. I prefer it adding. So see, how do I take it? I go as follows. I think I'm multiplying minus 4 to C1 elements. I think I'm multiplying minus 4 to C1 elements, and then whatever I'm getting, I'm multiplying minus 4 to the elements of C1, and whatever I'm getting, I'm adding it to C2. This is how I perceive it. Okay, and if you go by this, how would you take it? You are multiplying 4 to C1 elements and subtracting. You would say that you are multiplying 4. You are multiplying plus 4 to elements of C1 and subtracting. So if you are multiplying 4, you will subtract. And if you are multiplying minus 4, you would add. You understand? So I hope I have made it clear.
So could you explain this again? I didn't understand this.
Definitely. C2 plus minus 4C1. See, C2 minus 4C1. This is C2 minus 4C1. C2 minus 4C1 is same as C2 plus minus 4C1. This much you understand?
Yes, sir.
Okay. Now, what is meaning of C2 plus minus 4 times C1? The elements of C1, we are multiplying minus 4. We are multiplying minus 4 to elements of C1. So see, this is elements of C1. I will multiply minus 4. So minus 4, minus 4, minus 4. And then whatever I get, I add it to C2 correspondingly. So what I would get here, I will get here, see, C1 doesn't change. 3, 1 minus 1, 3, 1 minus 1. C3 will not change. Minus 1, 1, 3. It is C2 which is changing. How it is changing? You are multiplying C1 with minus 4 and adding. So multiply minus 4. It is minus 12. Add it. So you get minus 11. Multiply minus 4. So this will become minus 4. Add it. So you get minus 1. Multiply minus 4. This will become 4. Now add it. So this is 5. Okay. What I did, I multiplied minus 4 and added to C1. Whereas in this, what is given? Multiply 4 and subtract, multiply 4 to C1 and subtract. That would also give you the same thing. It is same thing. See, C1 that doesn't change. What is it? 3, 1 minus 1. C3 doesn't change. Minus 1, 1, 3. Now multiply 4. Multiply 4. But this time, whatever you will get, you will subtract. Okay, because you are multiplying 4, you are not multiplying minus 4. So when you multiply 4, this will become 12. 1 minus 12 minus 11. When you multiply 4, this will become 4. 3 minus 4 minus 1. When you multiply 4, this will become minus 4. Now subtract. So 1 minus of minus 4 is 5. See, we are getting same thing. We are getting same thing. Is that clear to you now, Sanjana? Now here we have another question, which is again based on transformation. See, we are asked to transform. The meaning of transform is to change. Okay, so convert. Transform is to change or to convert. So they say transform this matrix. We have to convert this matrix into an upper triangular matrix. We have to convert this into an upper triangular matrix. See, this is a square matrix. This is a square matrix. And what we have to do, we have to convert this square matrix into an upper triangular matrix. They say by suitable row transformation. Now see students, what do I do? First of all, what is an upper triangular matrix? See, a square matrix in which all the elements below the principal diagonal elements, below the diagonal elements are 0. So suppose here I have a matrix alpha, beta, gamma, 0, A, B, 0, 0, C. Okay. So here what you say, you see that you have one square matrix, and in that square matrix, see, this is the diagonal of the square matrix. These are the diagonal elements. Okay, these are the diagonal elements. Now below the diagonal elements, what you notice that all the elements are 0. All the elements are 0. So you call such a matrix as an upper triangular matrix. It is upper triangular matrix, such a matrix. Okay. So that is what the question here is. What they want you to get an upper triangular matrix from this matrix. From this matrix, they want you to get an upper triangular matrix. So let's begin. This question is very interesting question, and at the same time very significant question, because what we are going to do here, we'll be using this kind of thing for solving problems on inverse of matrix. So here I'm writing what we are going to do in this question. We are going to use when we will learn inverse of a square matrix, inverse of a square matrix. So this is something which we are going to see in the future lectures. So whatever I'm going to teach you now here, it will be used here. So I want you all to be watchful and pay attention. So let's begin. Okay. So you know what? I will write this. I will take this matrix here. I will take this matrix here, and this matrix is 1 minus 1 2, 2 1 3, and 3 2 minus 4. Okay. What I want below the diagonal all the elements 0. So I want this to be 0, 0, and 0. Remember that. I want these elements to be 0. See, how do I do it? How do I do it? I write R2 changes to, see, you want 0 here, you want 0 here, you want 0 here, you want 0 here. Okay, so learn the technique. See, so when I want 0, I will go one by one. Right now, I'm thinking about this element which is in R2. I'm thinking about this element. I will go one by one. Okay, I'm going to get 0 here.
So just a question.
Yeah.
Instead of changing R2, why can't we change C1? Because if we change C1 and C2, then like we'll get the three elements.
But then it is said na suitable row transformation.
Oh, okay.
In the question,
Immediately.
they have specified it is row transformation.
But if it wasn't specified, could we have done it in that way? That was my question. Like if it wasn't specified by suitable row transformation and it was written by suitable transformation, could we have changed
See,
C1 and C2?
C1 and C2
Yeah, to make it into an upper triangular matrix.
to make it an upper triangular matrix. The fact is we are going to use column transformation also, but then both are, see, you cannot prefer one method over the other method, because both are equally good, equally significant. You cannot say that this one is easy, that one is difficult. You cannot say that way. These are
No,
two
sir,
methods.
I'm not saying that way. I was just asking that if it wasn't written, could this also be done?
Yes, yes, why not? If you want to change it, see, an upper triangular matrix is always an upper triangular matrix. This will be 0, 0, and 0. If these three are 0, it is an upper triangular matrix. Now, how do you bring this changes? It is up to you. If I'm using row transformation, then I'll be doing something which I will do now. Okay, so I think the ideas will be clear. Let me complete it. Okay, and then I will do one thing. The same question I will solve by column transformation. Though they are not asking for it, I will do it. Okay. Should I go ahead now?
Yes, sir.
Okay. So see students, what I do, I want 0 at this place, and at this place. Okay. So I will go one by one. When I'm thinking of 0 at this place, I'm simply not bothered what is happening at other places. I'm not bothered. I'm thinking of 0 at this place, so I'm not bothered what is happening at other places. Simply not bothered. Okay, I'm thinking of 0 only at 2. Only at 2. This is what is my aim right now. So you have to follow the ideas as I am giving it to you. So see here what I write. I write R2 changes to R2. So you can ask me that why did you write R2 changes to? It is because I'm thinking of getting 0 here, and this element is in R2. It is in R2, so I will have to write R2 changes to. Then you can ask me, sir, but when you will change R2, then these two will also change because they are also in R2. Let them change. I'm not bothered. I told you in the beginning, I told you the beginning that I am interested only in this, and that is in R2. So I will write R2 changes to R2 plus minus 2R1, minus 2R1. Now you can ask me that how do you know it is minus 2R1 that I have to add? See, I want to make this 0. And what it is plus 2. When will plus 2 become 0? Only when you add minus 2. Only when you add minus 2. Only when you add minus 2. And how do I get minus 2? See, it is 1. So in 1, if I multiply minus 2, if I multiply minus 2 in 1, it will become minus 2 and then I will add. I will add. So minus 2 R1. Why minus 2 R1? Because in R1, I noticed that in R1, I have 1 here, which I want to make negative 2. So I write minus 2 R1. Then you can think, but sir, you are multiplying minus 2 to R1. So that minus 2 will also multiply this element and this element. Let it multiply. I am not bothered. I told you. Those changes you just cannot control. They will happen. Let them happen. You do not have to bother about those changes. Okay. So what I wrote R2 changes to R2 plus minus 2 R1. So the next step, see, you will get the next step. R1 will not change. So 1 minus 1, 2. R3 will not change. 3, 2 minus 4. R2 will change. R2 plus minus 2 R1. Multiply minus 2, add it. 0. Multiply minus 2. It will become 2. Add it. 3. Multiply minus 2. It will become minus 4 and add it. Minus 1. Okay. After this, what you will do? You have to, see, you got 0. Now you want this to be 0. You want this to be 0. So see, to make it 0, once again, I will use R1. I will use R1. So I write here, R3 changes to R3 plus minus 3R1. See, this time I'm writing minus 3R1. Why? Because if I multiply minus 3 here, minus 3, are you getting? If I multiply minus 3, then this will become minus 3 and adding it here, it will become 0. It will become 0. So how do I understand minus 3 I want? Because this this is the place where I want 0 and it is plus 3. How will plus 3 become 0? If you add minus 3. And how will you get minus 3? If you multiply minus 3 with 1. So the next thing I will get is, see, R3 changes to, R1 will not change and R2 will also not change. 1 minus 1, 2, and R2 will not change. 0, 3 minus 1. What will change? R3 will change. How? See, minus 3 R1. Multiply minus 3, add it. 0. Multiply minus 3. So this will become 3. Add it. 5. Multiply minus 3. It will become minus 6. And add it. You get minus 10. You get minus 10. So I got 0, 0. Now it is time we think of changing this to become 0. See, I want to get this 0. That is what is our aim. We want upper triangular, so we want everything below the diagonal 0. So these are the diagonal elements. I want below this 0. Here I have 0, 0. Only thing left is this. Okay. So let's begin. How do I make 5, 0? Listen, students. To make this 5, 0, remember, it's a rule. It's a thumb rule. You will not do what you feel like. Do not, do not use your ideas here. Okay, because those ideas may not work. You have to go by the rule which I'm saying. See, here Remember, what did we do? How did I get 0 here? I got 0 using this 1. See, I'm using this 1. Okay, let me first write it. See, I got 0 at this place. I got 0 at this place using this 1. Then I got 0 at this place using this 1. This 1. Okay. I cannot get 0 here using this 1. I cannot. Why? Because this 1 can be used only for corresponding zeros. For this 5 to become 0, see, this 5 to become 0, what I will have to do? I will have to first convert this 3 to 1. See, I will make here 1. Here I will try getting 1. Once I get 1 here, then once I get 1 here, then I will use that 1 to make this 0. To make this 0. Using that 1, I will get 0 there. Okay. See, you all would be thinking, I tell you as a beginner what thoughts can come. You all would be thinking, sir, we have already got a 1 here. Why not use this one? My dear students, you will not do that. You will not do that. Some of the students might be thinking, this is minus 1. If I multiply 5 to it, if I multiply 5 to this will become minus 5. And minus 5, if I'm adding, this will become 0. But you will not do it. You cannot do it. Why? Remember, students, if you do that, what would the transformation be? The transformation would be R3 changes to R3 plus 5R1. You are multiplying 5 in R1. You are multiplying 5 in R1 and then adding to R3. Remember, that would change. That would change even this. Because when you use a transformation, it is for that particular row, and then it gets used to all the elements. It is not that only this will change, this will become 0, but then this will become 5, which was already made 0 by you. It was already made 0 by you. So that is what I am saying, that in this problem you are going to learn certain nuances, certain ideas which you will follow for the problems that are going to come in future lectures. So what I said you will not use that negative 1. Remember, student, it's a thumb rule here. What is the thumb rule? The thumb rule is, after you have got 0, after you have got 0 in these two places, when you are going for this 0, you will always use the second element. You will always use the second row element. You will use always this element. Why? Because if you are using that element, you can be worry free. You can be worry free. You know, you are not bothered. You do not have you do not have an issue of this getting changed. When you are using 3, this will not change. Why? Because the corresponding element is 0. The corresponding element is 0. Now, if this is 0, even if it is added here, it will never become, this will never be changed. That will never be changed. So let us do this. See what I do here. I will make, what I will do is, I will make this 3 1 first of all. So here I write I write here R2 changes to R2 changes to 1 upon 3 R2. R2 changes to 1 upon 3 R2. Okay. So I will get here 1 minus 1, 2, 0, 1 minus 1 by 3. I'm multiplying 1 by 3 to the elements of R2. Okay. And 0, 5 minus 10. Now I do what I want. What did I say, my dear students? I want 0 here. I want 0 at the place of 5. So see, how do I do it? I write here R3 changes to, why R3 changes to? Because this is in R3. R3 changes to R3 plus minus 5 times R2. See, what am I planning? My dear students, what I'm planning? See, I will multiply minus 5. So this will become minus 5 and then add it. I hope you all are following what I'm saying. So here I get R3 changes to R3 plus minus 5 R2. So R1 changes, no. 1 minus 1, 2. R2 changes, no. 0, 1 minus 1 by 3. Will R3 change? Yes. How? You are multiplying minus 5 to the elements of R2. So here you multiply minus 5. See, this is 0. 0 into anything is 0. So when you add that here, 0 when you add to 0, when you add 0 to 0, that will remain 0. Then multiply minus 5 here. So this will become minus 5. When you add minus 5 to 5, it will become 0. 5 plus minus 5. And see here. Here you multiply minus 5. So when you multiply minus 5, that will become 5 by 3. See, minus 1 by 3 into minus 5 is 5 by 3. And then you add it to minus 10. So you add it to minus 10. This will become minus 30 plus 5 by 3, minus 25 by 3. And this is the upper triangular matrix. See, students, you got that upper triangular matrix. You got it. You got the upper triangular matrix. This is it. This is required upper triangular matrix. The next topic that we are taking is inverse of a square matrix. Inverse of a square matrix. Now students, as I'm writing here, inverse of a square matrix, it makes this thing very clear that only square matrices have inverse, only square matrix. Okay. Now I'm writing a statement, and that statement is highly significant. And why is that statement significant? You will know when you will read it. See, I write, consider two non-singular square matrices, two non-singular square matrices. Consider two non-singular square matrices A and B such that A into B is equal to B into A is equal to I. Then A and B are said to be said to be inverse matrix. They are said to be inverse matrix or simply inverse because they are matrix only. They are said to be inverse of each other. They are said to be inverse of each other. So let me now highlight those important words in this statement. You wrote consider two non-singular square matrices. See, you are writing non-singular square matrices. What are non-singular? A non-singular matrix is a square matrix whose determinant value is not equal to 0. So here it says two non-singular square matrices A and B. So remember students, these two matrices A and B both are non-singular. That is, when you find the determinant of A, it should not be 0, and determinant of B is also not 0. They both are non-singular matrix. This is very important condition. Okay, if you have the matrices which are singular matrices, then their inverse will not exist. The inverse will not exist. If suppose I have a matrix, and suppose matrix C determinant is equal to 0, so what you say, you will say C is a singular matrix. You will say C is a singular matrix. Remember students, if you have a singular matrix, then you cannot talk about the inverse of that matrix. The inverse of this matrix will not exist. You cannot have inverse of C. That is why this condition is most important condition. What? The two matrices are non-singular square matrices. Okay, let's go ahead. Now move ahead. What does it say? It says consider two non-singular square matrices A and B such that A into B equal to B into A. Now this is important. Students, if you remember in the multiplication of matrices, when I taught you, I said that two matrices, when you multiply, then suppose you have two matrices P and Q and you multiply them. So this one you call PQ, where P is the prefactor and Q is postfactor. P is prefactor, Q is postfactor. Whereas in this, what you have the reverse. You have Q as prefactor and P as postfactor. And what we have learned in multiplication of matrices, we learned that PQ PQ is not equal to QP in general. In general. What is meaning of in general? In general means all the time, without second thought. Okay, so PQ is not equal to QP in general. See, for example, suppose I say X and Y are two real numbers. X and Y are two real numbers. They are what? They are real numbers. They are not matrices, please. X and Y are two real numbers. Now, what you know about them? If X and Y are two real numbers, then you can write X into Y equals to Y into X in general. In general, they are equal in general. That is, they'll be equal all the time. All the time. If you have two matrices, I'm sorry, if you have two real numbers, then the change in the order of their multiplication will not change the value. 3 into 5, 5 into 3, both are equal. 7 into -2, -2 into 7, both are equal. The number multiplication is always equal even if the order changed. But in matrices, it is not so. In matrices, it is not always equal. Sometimes it may be equal. And that is what is being said here. Okay, this is a rare thing, rare. You understand the meaning of rare? Rare is something which does not happen all the time. It's a rare possibility, but then it is happening here. That is what is being said. AB equals to BA. AB equals to BA. And both are equals to identity matrix. A into B equals to B into A equals to I. That is identity matrix. That is you can also say AB equals to I, BA is also equal to I. Both are, when you get AB, it is identity matrix. When you get BA, that is also identity matrix. And remember, students, when this happens, then what you say? You say A and B, they are inverse of each other. They are inverse of each other. Okay, further. Now I write certain note. Now here I will write some note, and that note you all have to follow. See, a matrix, if a matrix is a singular matrix, if a matrix is a singular matrix, then if a matrix is a singular matrix, then its inverse will not exist. Then its inverse will not exist. Okay, what is, see here, look at this, in this discussion, if I ask you what is inverse of A, you will say B. Here what you will say, if I ask you what is inverse of A, you will say B. If I ask you what is inverse of B, you will say A. They are inverse of each other. Why? Because A into B, B into A equals to I. And remember, students, this is happening only because both are non-singular matrix. Now suppose here I give you a matrix C, and C happens to be a singular matrix, that is its determinant value is equal to 0. And now I ask you, can you find the matrix, can you find the inverse of C? You will say no. If I ask you, can you find inverse of C? You will say no. Why? Because C is a singular matrix. It is a singular matrix. So the first condition for a matrix to have its inverse is it should be a non-singular matrix. Okay. Next. This is first point. No. Second, if if inverse if inverse of a matrix exists, if inverse of a matrix exists, then then it is unique. It is unique. Now what does it mean? Suppose I give you a matrix here. I give you a matrix here, and it is a non-singular matrix. I give you a matrix here, and it is a non-singular matrix. So its inverse will exist, yes. And you find its inverse. You find its inverse, and you got the inverse as this. You got the inverse of this matrix here. Okay, this is yellow matrix, and this is yellow matrix. And what is the yellow? What is the inverse of the yellow matrix? The inverse of yellow matrix is red matrix. Okay, what is it? It is red matrix. Wait, wait. This is yellow matrix, and the inverse of yellow matrix is red matrix. Got it? Yeah. Now, what I do is I also find the inverse of this matrix. Now, when I find, see this inverse you found this inverse. Okay. And what is this? It is inverse of yellow matrix. I also wish to find the inverse of yellow matrix. Remember students, I also must get the same answer. I also must get the same answer. It means the inverse of a matrix is unique. Whoever finds now inverse of this matrix, they should all get the same answer. If that is what is said, if inverse of a matrix exists, then it is unique. Then it is unique. Inverse of a matrix will be one and only one matrix. It is not that you are solving inverse of a matrix and five students are solving and all of them are getting different answers. No, that will not happen. They will all get one single answer. They will all get one single answer. Okay, now see students, the next point that we have is uh, so in this discussion, okay, I'll write on the next page. See, in the earlier in the discussion on the last page, we had AB equals to BA equals to I. Then what I said A and B, I said A and B are inverse of each other. Inverse of each other. That is all okay. But then it is customary to write inverse of matrix A in a specific way. So I will write that here. See, I write it is customary. What is meaning of customary? Customary means something that is in custom, that is being followed, that is being followed. Okay. So I write it is customary to write to write inverse of A as inverse of A as, see, this is the symbol. This is the symbol for inverse of A. And how do we read it? We read it as A inverse. We read this as A inverse. It is customary to write inverse of A as this. Similarly, and and inverse of B, inverse of matrix B as B inverse. This is customary. That is, it is being followed. It is being followed. So how do I write inverse of matrix A? I will write inverse of matrix A like this. And how do I write inverse of matrix B? I will write it like this. So here what I said, try to understand students. Here what I said. I said A and B are inverse of each other. Here I said that A and B are inverse of each other. Then I am saying in the next line that we normally follow, it is in fashion to write inverse of A as A inverse. It means what I'm trying to say is A inverse is B. I said here that B is inverse of A, but then I'm saying that we write inverse of A like this. It means B is A inverse. Perfectly all right. And what I'm trying to say is A is B inverse. A is B inverse. This is what I'm trying to say. Because A and B are inverse of each other. A and B are inverse of each other. So what I can now say, I can simply say that this equation which I have here, this equation can now be written as A into A inverse, A into A inverse equals to A inverse into A equals to I. You can write it like this. A into A inverse, because B is A inverse. B is inverse of A, that is A inverse. B is A inverse. So this equation will become A into A inverse equals to A inverse into A equals to I. You can write it like this. For that matter, you can even say that you can even say that B into B inverse equals to B inverse into B equals to I. See, because this is B inverse. So B inverse into B equals to B into B inverse equals to I. I hope you all followed this fact.